Hey guys, Dr. C here, and welcome back to Data Analysis and Statistics for the Social Sciences. In this video, we're going to talk about the design of experiments. So basically, we're going to talk about this idea about how, with a little planning, and if we just sort of change how it is we conduct our studies, we can make them better. We can make it easier for us to see differences between groups just by doing our study in a different way. So let's get to it. So the first question I really have is, what does it mean to design something? Now, clearly, all of you are familiar with design. If you think about your lives, you've got all these things that you've purchased, and they've all been designed. If you think about shoes, for instance, we've got shoes for when it's raining, we've got duck boots, and we've got shoes when it's snowing, we've got snowshoes, we've got cleats for people who like to do sports in the grass. And of course, there's a whole world of design aesthetic. So we have shoes that are literally cooler than other shoes. So all of this is intentional. When it comes to statistics, it's the same way. We can conduct a study, but there are different ways that we can conduct a study. And some of those studies are better, or I guess you could say more powerful than other studies. So today we're going to talk about design, we're going to talk about designing experiments, we're going to talk about how it is you can conduct an experiment, how you can compare two groups, and do it in a more efficient manner. So with all the tools that we talk about in this course, we've got all these different assumptions, and if those assumptions are satisfied, then we can do the statistics and we can trust the results. But here's the thing. Those are just like the minimal assumptions. So if you can verify those assumptions, then you're good to go. But you can be more aggressive than that. You can say to yourself, okay, I've got the minimum assumptions satisfied, but what else can I do? What other assumption can I make? How else can I design my study? And if you can make that additional assumption, and if you can hold to it, then you're able to do a lot more when it comes to your results. You can literally do more with less. You can ask interesting questions, find amazing discoveries, and do it with requiring a lot less people. So when it comes to this week's method, the additional assumption is this matched pairs assumption. Effectively, what we do is we take our analytical units, or in your guys' case, your students, and we measure them twice in some way. So, we may want to compare how things were at one time point to another time point. So what we do is we basically just take one group of students, measure them once, and then we measure them again at a second time point. So this is kind of challenging because you have to keep track of the same people. But if you can do this, then you can really examine whether or not things have changed. And you can do it with one group of people instead of having to go out and find two entirely different groups of people. So the tool that we're using is this difference between two population means method with a matched pairs design. So this involves two variables, and effectively it's just one variable measured twice. So it could be the same variable at time 1 measured again at time 2. Or you might have two related contexts. So when it comes to your guys' research, you might think of things like fear of crime at night, or fear of crime during the day. Or you might think of things like, how much did you weigh when you started college versus how much do you weigh now? So we've got the same individual, but we're measuring them twice. So we've got two columns of information in our database. It's basically the same question, and we're measuring it a second time. Then what we do is we take these two columns of information and we subtract them from each other. So we find the difference. And then we focus on this column of differences. This becomes our new variable. This is the new variable that we're going to test claims about when it comes to, on average, how people are responding. So generally when it comes to using this tool, it works in the same way that we're used to. So we're going to test bold claims about a population mean of differences. Here we've got one population, So one population of differences. It's going to assume that we're talking about the mean of the differences. So again, we're talking about an interval or a ratio level variable that's measured twice. So when it comes to using this tool, it only works for continuous variables. It doesn't work for anything that's categorical. Now, in this situation, we have a dependent samples assumption. So the idea is that if you're measuring somebody and then you're measuring them again, well, there's a dependency there. So even though my responses might not influence anyone else's responses, my responses at one time point are going to influence my responses at another time point. So this tool takes that into account. And then of course we have our random sampling assumption, which in this course, the data have already been collected. I just had some students go around campus, survey other students. They did this in the way that was most convenient for them. No randomization was employed. So to show you how this works, we're going to draw on a study that I conducted. So I worked with the Riley County Police Department on their initiative Laser Point. So I don't know if any of you guys are familiar with the idea of hotspot policing, but there's this idea that certain locations on a map are consistently higher when it comes to crime than other locations. So what we decided to do was to conduct an experiment. We got 48 different hotspot locations. We measured the number of calls for service in each of those locations. And then the Riley County Police Department initiated a new kind of policing. So they were going to go out in the world, they were going to be more engaged with the community, talk to people, get out of their cars. And then at the end of a year, we were going to see whether or not that changed the number of calls for service. So we had 48 locations, and I measured the number of calls for service at one time point, and then I'm basically comparing each location to itself at another time point. So here's the data that I collected. So every one of these rows represents a different hotspot, and you'll notice that we got two columns of information. So here I've got the number of calls for service in 2011, and then again I've got the number of calls for service for each of these locations in 2012. So the idea is that we have these 48 different units, and we've basically measured them twice. So on the one hand, you can think of it like we're asking the question, on average, are the 2011 calls for service greater than the 2012 calls for service? Now, another way that you can think about that would be to look at those two columns of information, take the difference. So in this situation, I've subtracted one from the other. So here for the first row, that first hotspot, I took the number of calls for service in 2011, and I subtracted from that the number of calls for service in 2012. So here we've got a difference of 12 calls for service. And I did the same thing for hotspot number 2. I had 30 calls for service in 2011, and then 8 calls for service in 2012. So here I get a difference of 22 calls for service. So the idea here is that, I'm looking at these different values for each of these two time points, and I'm taking the difference between them. So if we look at all these differences, we can kind of think about what it is these differences tell us. So these differences tell us by how much the two time periods differ, but they also tell us the direction of the difference. So in this case, if I've got a difference and it's a positive number, that means the calls for service in the past, 2011, were greater than the calls for service in 2012. So effectively what we do by creating this column of differences is we go from that 2 population situation into a 1 population situation. And we change our question a little bit. So now our question is, on average, are the differences between 2011 calls for service and 2012 calls for service, are these greater than 0? So remember, if you look at this calls for service column, if you look at all these differences, if it's a positive number, that means the number of calls for service were bigger in the past than they were in 2012. So what I'm interested in is, on average, are these differences bigger than 0? Were there more calls for service in 2011 than in 2012? And the way this works is just using some math logic. So, with the previous material we talked about, we may have been interested in, well, was x greater than y? Well, if we do a little bit of algebra, we can see that that's the same as saying, is x minus y greater than y minus y? And if we simplify the math a little bit more, we can say that this is the same as saying, is x minus y greater than 0? So we're really going from that two population situation, is one thing greater than another thing, and we can transform that into a one population situation by saying, is the difference between that one thing and that other thing, is that greater than 0? So again, when it comes to this research, the original question was, is the number of calls for service greater in 2011 than in 2012? And that's the same thing as saying, is the differences between 2011 and 2012, is that greater than 0? So when it comes to your guys' research, you're going to go to your database, you're going to find your two related variables, you're going to create a column of differences. And then we're going to look at this question, on average, are those differences greater or smaller than 0? And then this will allow you to do that two population means method using that claim about a single population mean method that we talked about earlier. So in order to do this, we conduct a test of hypotheses. And again, here we've got our 6 steps. These are the same 6 steps we've been seeing all semester. So step 1, we state our null and our alternative hypotheses. Step 2, we set the significance level. Step 3, we determine the appropriate statistical method and then state and verify all the assumptions. Step 4, we determine the p-value. We use the flow chart. You show your work. Step 5, we compare the p-value to the significance level. Do you reject or fail to reject the null hypothesis? Why? What do you do next? And then step 6, we interpret our results. So remember, in this course, interpretation is super important. We want to make discoveries about social life for our own understanding, but we also want to be able to share that information with the world so that people can make policy changes and do their jobs a little bit better. So here we provide a technical interpretation as well as our everyday interpretation. For this study of initiative laser point, we have step 1, state the null and the alternative hypothesis. So the null in this situation is that there's no mean difference in calls for service between 2011 and 2012. So again, you can think of this as that doubting scientist hypothesis. There's no difference between the two contexts. And then we have the alternative hypothesis. So here we have that the mean calls for service in 2011 is greater than those observed in 2012. Now again, when it comes to doing this kind of study using this particular method, we only have one null hypothesis. And that's always going to be that the mean of those differences is going to be equal to 0. So if you take all the information in column 1 and you subtract it from column 2, then on average, all those differences are going to be pretty close to 0. Now when it comes to the alternative hypothesis, you have some options. So if you think that things were greater in one context than the other, you can do a greater than test. So this is basically saying that if you look at all of those differences and you think things were greater in the first context than the second context, then basically we're saying on average those differences should be greater than 0. Or you can do a less than test. So if you think about context 1 and you think about context 2 and you think about the differences between them, you think things got bigger, well then on average those differences should be negative. So in this case you'd be doing a less than test. Now you could also do a not equal to test, but in this course we're mainly going to be focusing on these greater than tests or these less than tests. Usually whenever we're comparing two groups, we have some idea of how they should differ. So we want to take that information into account So by doing that, it makes our studies more powerful. It allows us to see differences when they actually exist. And when it comes to working with SPSS, we have to be really careful about the order of how we talk about these groups. So as logical thinking people, as you all are, we recognize that there are ways to say things that mean basically the same thing, even if we say them in different ways. So if I said to you guys that the difference between context 2 and context 1 is basically 0, that's the same thing as saying the difference between context 1 and context 2 is basically 0. So you know it, I know it, but the problem is SPSS doesn't know it. So as you use this method, you need to be really careful. You need to make sure that when you subtract things, when you think about the order of how you subtracted things, that's the order you use as you use this tool. You want to make sure that the order of the groups is consistent throughout. So when it comes to you guys transforming your variables, creating this new variable of differences, you're going to have your first variable, and you're going to subtract from that your second variable. So whatever variable you pick as your first variable, that's your context 1. That's your group 1. And then whatever you subtract from it, that's going to be your context 2. That's your time 2, your group 2. So however you do these differences, when it comes to your null hypotheses and your alternative hypotheses, you're going to want to make sure that you preserve that order, that you're really consistent. Otherwise, your results are going to be wrong. Step 2, we're going to set our significance level. So again, before we do this test of hypotheses, before we test this bold claim, there's no difference between these two groups, we need to set a threshold. So in this, using this tool, just like any other statistical tool, we're making a decision. So there's always a chance that whenever we make a decision, that we're the ones who are going to be wrong. So what we do is we set our significance level to 0.05. We say to ourselves, okay, we know there's a chance that we could be making a mistake, but as long as that chance is really small, as long as it's less than 0.05, then we're good to go. Step 3, we then determine the appropriate statistical method and check all the assumptions. So again, this is where you need to name the method we're using. You need to identify all of the different assumptions, and you need to think about them. You need to verify them. You need to make sure that they aren't grossly violated. So this is really important. This step is important because it helps you as a researcher stay focused. It allows you to make sure that you're using the right method. It reminds you to check all the right assumptions so that you can actually use this tool to make the discoveries that you care about. It's also really important because when it comes time for you to share your findings with other people, they're going to want to know, well, how did you get these results? What did you do? And these are the crucial things that you need to talk to them about. You need to talk to them about these assumptions. You need to talk to them about how they weren't grossly violated. And if you can do that, then everyone can look at your results and go, okay, these results, we can trust them. So the method we're using is this difference between two population means method with the matched pairs design. It assumes two populations, and we're going to say that this is okay because we have one population of locations, and this has been measured in two different contexts. So for Initiative Laser Point, I've got different locations. Those are my units of analysis. For you guys, you're going to have students, and you're going to be measuring those students in two different contexts. It also assumes population means, so we can say this is okay because the claim proposed is about the mean calls for service. More specifically, it's about the mean differences in calls for service. We also have our third assumption. In this case, though, it's not the independent assumption, it's a dependent assumption. So when it comes to this kind of tool, every individual, every unit of analysis is being measured twice. So in my situation, I've got these locations. They were measured in 2011, and then they were measured again in 2012. So whatever happens in those locations at one time point is going to influence what happens at that location at another time point. So in this situation, our assumption is that there's a dependent sample structure. And here I can say it's okay because the location at time 1 influences itself at time 2. And then of course we have our random sampling assumption. So when it came to this research, just like your guys' research, this assumption was violated. So it's not okay because, whichever locations that I looked at, those were just the locations that were available. That's all there was in my jurisdiction. So this assumption has been violated, and for your guys' research, it's also going to be violated. So you just need to say that has been violated, that it's okay for learning purposes, it's all right. I just want you guys to be able to see how this tool works from the beginning to the end. So step 4, we determine our p-value, and here we're going to use SPSS. So again, SPSS is going to do most of the heavy lifting for us. It's not going to do everything, but it will get us most of the way there. So you'll take your information, your column of differences, and you'll use the same routine we talked about previously. So you'll put that into SPSS, and you'll get a table that looks like this. Now, when it comes to this table, there are 2 key pieces of information that you need to focus on. So one, we need this 2-sided P number, and we also need this T number. So write those down somewhere. You can write them in a Word document. You can write them down on a scratch piece of paper. So once we have these 2 numbers, then we can start finding the true p-value. So to do this, we also need our alternative hypothesis. So here we have our alternative hypothesis that the mean calls for service in 2011 was greater than those observed in 2012. And we need this alternative hypothesis because this is going to tell us which of those 3 paths we're going to go down to find that true p-value. So in this situation, we see this word greater than. So we have one context that we think is greater than the next context. So here we're doing this greater than test. So we're going to go down this 3rd path. So the next thing you want to do is you want to look at that T number and you want to think about it. Is it positive or is it negative? If it's positive, you're going to do one thing. If it's negative, you're going to do something else. So here we can see that the number is positive. So T is positive. So this tells me that I need to continue down the path. So here at the bottom, I get to the instructions that I need to adjust the p-value. So here it says that I need to divide the value under the column 2-sided P by the number 2. So in order to get the true p-value, I take 0.055 and then I divide that by 2 and I get 0.0275. So that's my true p-value. Step 5, I'm then going to compare the p-value to the significance level. So we've got our threshold. Again, we're saying, okay, if there's a very low amount of risk, then we're going to go ahead and say that there's a difference between the 2 groups. But if there's a lot of risk, then we don't want to say that. So in this situation, the p-value is this 0.0275. 0.0275 is a number that's less than 0.05. So we reject the null hypothesis and we accept the alternative hypothesis. So step 6, we then interpret our results. So we have our technical interpretation and our everyday interpretation. So again, we need 2 interpretations. We're going to present our findings to people who've taken stats courses before. So whatever we tell them, they're going to understand. But we also want to be able to share our findings with everyday people. We want to share our findings on social media. We want to change the world. So we need to come up with language that everyday people can understand. So in this case, our technical interpretation is that at the alpha equals 0.05 level, we have sufficient evidence to conclude that the mean number of calls for service was greater in 2011 than in 2012 over the long run. And then we've got our everyday interpretation, which is that the doubting scientist is wrong. The calls for service decreased from 2011 to 2012. Okay guys, so that's the video. So in this video, we talked about the design of experiments. So we thought about how it is we could use a tool that we already know, it's comparing 2 population means method, and be a little bit more aggressive about it. How we're able to think about our research and design it in such a way where we can not only use the simpler method, making a claim about a population mean that we talked about previously, but also use a tool in a way so that our results are even more efficient. So, if you've ever been told in your life to do more with less, this is a tool that lets you do that. This is a tool that lets you look at one group of people and use that one group of people to understand how things change over time. If you think about doing any kind of research, going around the world, collecting data, talking to people, it's all a lot of fun, but it's also a lot of work. It's also a lot of time. So if you can just look at one group of people and understand how they are in two different contexts, then you can literally do the kind of study you want to do. Compare two different groups, but you can do it with half as many people. Incredible. So in this video, we talked about how it is you can design your study, how you can be a little bit more aggressive, how you can focus on one group of people and find differences and do it in a more efficient way than we talked about previously. Okay guys, so that's the video. If you have any questions, just let me know.